Okay, good morning everyone. My name is Dr. Nagaraju, working as Assistant Professor in the Department of CSE and ML, working in the Institute of Aeronautical Engineering, Hyderabad. Today I am here to present one of the concept from module number 2, which is called as problem characteristics. So before moving into this, let us try to make some kind of review of the previous session. So in the earlier session, we have discussed about this production systems. So in the production systems, we came to know that there are 4 important elements are there. The first one is the set of rules. The second one is the control strategies. The third one is the knowledge base, and the fourth one is the rule applier. So these are the 4 essential elements in which we are going to make use while developing the production systems. So at the end of the session, during these production systems, at the end, we have discussed, means we have just given an introduction to the heuristic search techniques. And we have also seen one example to identify or to determine which is the shortest path among the 2 given points. And we have also seen what makes the heuristics, what makes us to solve the AI problem by making use of these heuristic problems. So in simple understanding, we can say that the heuristic search techniques will give us some additional information about the problem through which we can make use of that information and we can solve the problems. Okay, what kind of problems it is, that completely depends upon the nature of the problem. So today we are going to discuss more concepts about this problem, which is called as here the problem characteristics. As I have mentioned that heuristic search techniques, there are a lot of heuristic search techniques which we can make use in order to solve the lot of AI related problems. But only the thing is, we need to clearly understand which one is the best suitable one. Means if you select a particular problem statement, to that problem statement, what will be the suitable heuristic technique? Why? Because a lot of heuristic techniques are there and the different types of AI problems are there. So which one, which heuristic technique we need to apply to solve a particular problem? That is the biggest question. So for that one, what we need to do is we need to understand more clearly about the different characteristics that a problem can hold. So in today's session, we are going to concentrate on the characteristics of the problem. Means we are going to study these characteristics of problem in order to identify or in order to describe the problem more clearly and try to understand which one is the best suitable heuristic technique to apply. Okay, so let us move into the concepts clearly. So we are talking about the heuristic search technique, and in this we are trying to understand what are the different characteristics of a problem. So as I mentioned here, it is heuristic search is a very general method applying to a large scale of problems. So this is the thing, means in the upcoming modules we are going to study more clearly how these heuristic search techniques are helpful for us in order to solve different kind of search process. So we can say that heuristic search techniques are going to give a lot of support for us in order to solve more complex problems even, and it is also going to be helpful in solving small class of problems. But only the thing is, we need to understand the characteristics of the problem. So our concentration will be on the characteristics of the problem. So let us try to understand how to choose the best one. As I mentioned just now, there are different kinds of heuristic search techniques available. So which one is the best suitable technique for the problem that matters? That's why we need to first determine, or we need to understand what will be the best heuristic search technique to solve our problem. So that's why the first question we are raising by ourselves is that how to choose the best one. Means among the available heuristic search techniques, which is the best available search technique. So for that one, we are going to study 7 to 8 different characteristics of the problem. Means once we understand the characteristics of the problem, easily we can identify which one is the suitable heuristic search technique to be applied to solve it. So the first characteristic we can say that is the problem decomposable. Is the problem decomposable? Means we need to check it out whether the selected problem is decomposed into several number of parts or not. Why? Because as we have discussed in the previous sessions, that AI problems is going to include both the simple problems as well as the more complex problems. When the problems are more complex, it will be very easy to implement the decomposition process. So in that case, what happens, we are going to divide the problem into several sub problems, and we will try to solve each and every sub problem individually. Later on, the results whatever we get for the individual sub problems, that we will combine together to get the solution for the main problem. Okay, so here we need to understand, means we need to see whether the problem we have selected is decomposable into several sub problems or not. Okay, and the second characteristic is the solutions, can the solution steps be ignored or at least undone? So what do you mean by this? Right, these kind of things we are going to see in the mathematical representations, especially means when you are dealing with mathematical equations, these kind of things will occur. Means whatever the solution you are trying to derive, if that solution means whatever the approach you are following to solve a particular mathematical expression feels that is not giving the best solution to you, so can I simply ignore that approach? Okay, or otherwise can I go back to the previous state and can I continue in a different way? Okay, so is your problem is related to this particular concept or not, that also we need to consider. Means the second characteristics of the problem is we need to see whether the solutions can be ignored or they can be undone. And the third one is the problem universe predictable? So what does it mean? What do you mean by predictable? Means are we going to predict what will be the next step? Means while solving a particular problem, think that you are in particular state. So what will be our next step after applying a particular rule or after applying a particular operator? Are we going to predict it? Means is it possible in the real world scenarios to predict what will be the next coming step to us? Okay, so that also we need to consider. And the fourth one is a good solution to the problem obvious without comparing to all the other possible solutions? Means how you are going to decide that the solution what we got is the best solution without making the comparison of other possible solutions. So your problem need to come in this particular category. Okay, so the different types of problem characteristics we are discussing is going to tell exactly the nature of the problem. So based upon that nature, if any of the heuristic search technique is finding to be applicable, then directly we will select that technique and we will apply to our problem statement. Let us move to the fifth one. So the fifth characteristics of the problem is a desired solution a state of the world or a path to a state? So what does it mean? Means whenever you have selected a particular problem and trying to solve it, is the solutions getting by you are stating any state of the problem? Means it is describing any state of the world or it is describing the path. For example, think that you are working with the common sense reasoning. Then in that case, what happens? It is the result will be the state of the world. If you are working with any kind of search techniques, then the result of your solution will be, if the result of your problem solving will be a path which is going to show in between the given points. So that we need to understand. Means whether your problem is related to, means whether your problem solution is giving any state of the world or it is giving any kind of path to the state, that we need to look it out. And the sixth one is a large amount of knowledge absolutely required? So what does it mean? Means we are going to understand what is the importance of the knowledge. Means do really we require knowledge to solve our problem or not? Okay, so and the seventh one is, can a computer is simply given the problem return the solution, or will the solution of the problem requires interaction? So what do you mean by that? Means if you are writing some kind of instructions or some AI program, and if that program is solving your problem, then what happens? Generally we will get the solution. But just providing that solution to the user is more than enough, or the user requires any kind of interaction with the computer in the further cases? That also we need to look it out. So let us try to understand each and every characteristics of the problem. So we have discussed so far the 7 characteristics. So during our explanation, we are going to elaborate that 7 characteristics into 8 different characteristics of the problem. And we are going to see the examples for each and every characteristic. Okay. So the first characteristic what we have discussed is the problem decomposable? So what does it mean? If you feel that any of the AI problem is given to you, and if you think that AI problem is more complex to solve, then can you decompose that problem into several sub problems or not? That we need to understand. So let us take 2 examples to understand how this decomposition will be there will happen, and how that decomposition will makes us in order to solve the problems. So let us take the first example, which is related to the computing expressions. So let us think that a mathematical expression is given to you, and that expression you need to resolve it. So we need to decide whether we need to determine whether this problem statement given to us is decomposable or not. So decomposable in this sense, if you consider this as the whole problem, can you able to divide this problem into several sub problems? Why? Because dealing the complex problem as a whole, it will not give the best results for us. So what we are doing, we are trying to do the decomposition, means splitting this problem into various sub problems. So what we will do, we will try to resolve the sub problems individually, and we will try to get the solutions for these three sub problems. So whenever we combine the solutions for these three sub problems, we are going to get the solution to the main problem. So that kind of process or that kind of approach, is it applicable to this computing expression or not, that we need to see. Okay, so we can clearly understand that. Okay, so we can clearly understand here, you see, this problem, what we have done is, we have divided into we have divided this main problem into three sub problems. Okay, main problem into three sub problems, and we are trying to resolve these three sub problems individually. Means this sub problem has got some kind of result. Let us think that it is some S1. Okay, so the other sub problem has given the some more solution. Let us think that it is S2. Then after, it may be this may be some S3, or this may be some S4. So what happened? First, we have taken a mathematical expression, and we have decomposed that expression into three different sub expressions, we can say. So in our problem statement, we are saying that we have selected a problem which is related to some mathematics, and we divided that problem into three sub problems. And what we have done, we have tried to individually resolve or individually solve the individual sub problems. So what happens ultimately at the end, we have got 4 sub problem solutions. So what we are doing at the end, we are going to combine all these sub problems to get the solution for this main problem. So what does this, here there is an arc. You try to understand, there is an arc wherever we have done some kind of splitting, where we have done some kind of decomposition. So what does this arc represents? This arc represents AND. This arc represent AND. What does it mean? Means if you want to solve this particular problem, or if you want to solve this mathematical expression, then you should supposed to solve all the 3 that present here. Similarly, if you want to solve this particular sub problem, so you should supposed to solve these 2 sub problems again. Okay, simply solving one sub problem, and you cannot say that we have resolved this one. It is not like that. Why? Because there is a AND arc in between these 2 sub problems. So what we are doing here, we are at the end, we are trying to combine this S1, S2, S3 and S4 together to get the solution for this mathematical expression. So what this explanation is telling all about means, the problem which is related to this mathematical kind of expressions, they comes under the decomposable things. Means the mathematical expressions or mathematical theorem related expressions can be easily decomposed into several sub problems, and we can easily resolve those sub problems very fastly. Okay, so if your problems are related to this kind of things, then we say that our problem statement characteristic is decomposable. Okay, let us try to take one more example, and we will try to understand whether this decomposable is applicable to any of the AI problems or not. Okay, so the second example is this one. We are talking about the block world problem. Okay, this is a block world problem given to us. So you need to understand the problem first. We are having the starting state and we are having the goal state. So with our understanding, we can say that a given state is there, means a state is given to us, and we are asked to move to the desired state. We are asked to move to the desired state. So ultimately what we have to do in between these two, we should supposed to take the decisions. So how can we make the decisions? Means whenever we are applying certain kind of rules, or whenever we are applying certain kind of operations, then the certain kind of operations means here the appropriate operations. Whenever you apply the appropriate operations, definitely your given state will move towards the desired state. Okay, so we should supposed to understand what are the operators that are applicable to this block world. Okay, so first we are trying to understand what are the operators that are applicable to this one. Then after we will try to understand whether this problem comes under this decomposition characteristic or not. Okay, so try to understand the operators of this problem. So what are the operators given to us? See, you try to understand clear x, on x comma table, clear x, clear y, and on x comma y. So all these things are called as the predicates. All these things are called as predicates. We will try to understand what these predicates more clearly in the coming sessions. Okay, you try to understand these are the predicates, which are nothing but some possible operations. Which are nothing but some possible operations what we can apply in order to solve this block world problem. So we will try to understand what these predicates are telling all about. If I say clear x, so what does it mean? Means the x block is clear. You try to understand this block world problem. Blocks world problem is nothing but arranging the blocks in a particular state. Means this kind of arrangement of blocks has given to you. So you should supposed to rearrange the blocks in such a way that you can get the blocks in this order which has given in the goal state. So for that one, in order to get this goal state blocks world, so what are the applicable operators we are having? So one is the clear x. So we are representing these predicates in the generalized way. It is not the specialized one. Means if I say x, in place of x, we can take any of the one. Either it can be A, or it can be B, or it can be C. So based upon the problem statement, it is different. Okay. So whenever if I represent the predicate in the generalized way, I can use these operators to any kind of problem which is related to this blocks world. So if I say clear x, so what does it mean? Means the x block is clear. What does it mean? X block is clear in the sense thing that there is an x block here and there is nothing in this on this x block. So when there is nothing in this x block, simply I will say that it is clear x. X is clear. So when x is clear, so what you can do, right? What you can do is, means you can do this one on x comma table. On x comma table. So what does it mean? Means pick up the x and put it on the table. If x is clear, then you can keep this x on the table. You can keep the x on the table, or otherwise you can keep the x on some other block also. You can keep the x on some other block also. So these are the two possibilities we are having in this case. So means if you want to make the move of this x block, then the block should be clear. That block should be clear. That means that there should not be any other block on x block. Similarly, for clear y also the same thing. Means if you want to move the y block, then that y block should be clear. Means there should not be any other block on the y block. So what does it mean here? Clear x and clear y. Means the x block is clear and also the y block is clear. Then what operation I can perform? Means on x comma y I can do. So what does it mean? Means put x on y. So if I represent, that means that x block is on the y block. X block is on the y block, means you are going to get this type of representation after doing the operation. Okay, x block is on the y block. So it is not this. It is x and it will be y. So if I say on x comma y, that means that x block is on the y block. So here x block is on the y block. Okay, so these are the possible operations we are having. So we need to understand, means we need to understand first of all whether this problem, means this blocks world problem is decomposable or not. Okay, so if it is decomposable, then afterwards we need to understand what are the possible operations we can apply on that one. Okay, so let us try to see first whether it is decomposable or not. Okay, so I am taking the same state which is the given state and the desired state. So what we are doing is we are trying to decompose this problem into two sub problems. So here two sub problems I have taken. Okay, means in order to achieve this goal state, what we are doing, we are trying to decompose this problem into two sub problems. So what is our first sub problem? We should supposed to resolve this one. We should supposed to get this particular state. Then after we should supposed to get this state. Whenever you combine these two particular states, why? Because it is an AND. So whenever you combine these two particular states, you should supposed to get this goal state. Okay, now let us try to resolve these two sub problems now. So on B comma C, so what does it mean? Means B block is on the C block. It means that B block is on the C block. But you try to observe, means if it is a case, means if you want to perform this particular operation, B should be clear. Okay, B should be clear, means there should not be any block on the on C. Then only you can keep the block B on C. So here if you observe in the given state, what happened? Already C is clear. C is clear. So you can write like this, clear. In place of X, we are going to write C if it is too specific. Previously, if I write clear of X, then it is general. Okay, so what happened here? Clear C is matching here. So in this case, what I can do? I can place this B block on the C block. I can place B block on the C block. So in that case, what happens? We are going to get this particular state. What is that? This is the table. Initially on A, on table there is A. On A it is C. On C it is B now. Okay, but so what does it mean? Means we have resolved this particular sub problem. We have resolved this sub problem. What is that? B block should be on the C block. If you observe here, what happened? B block is on the C block. Okay, so one sub problem we have resolved. Let us try to resolve this particular sub problem. What is that? On A comma B. So what does it mean? Means A block should be on the B block. A block should be on the B block. You try to observe, B is on the table. B is on the table. On B we are having, A is on the table. On A C is there. On C B is there. Do the comparison between these two states. This is the state what we have got. Okay, we can say that this is a new state. We can say, right, we got the new state. From this new state, we are doing some kind of comparison whether this is our goal state or not. So when we do the comparison, that is not our goal state. The newly came state is not the goal state. That means that we have not resolved this on A comma B still. But if you observe more clearly, what is happening here, in order to resolve this particular case, we need to disturb these blocks. We need to disturb these blocks. That means what is happening here, whenever you are trying to resolve this particular sub problem, you should suppose to disturb the sub problem which is already solved. Why? Because on B comma C is already solved. But in order to achieve this sub problem, you are disturbing this sub problem also, for which you have already got the solution. So what does it mean? Means there is a dependency. You try to understand. There is a dependency. Okay, sorry. There is a dependency. There is a dependency between these two sub problems. But actually, what is the case? If your problem characteristic is decomposable, that means that the sub problem should be independent to each other. Means the solving of one sub problem should not affect the solving of another sub problem. Then only you can apply this decomposition and you can divide the complex problem into several sub problems. But in this case, what is happening? Here we have observed that there is a dependency between the two sub problems. So with this observation, we can clearly say that the Bloxwald problems are the Bloxwald rearrangement problems does not have the characteristic of decomposition. Means you should not supposed to decompose the problems into several sub problems which are related to this Bloxwald. Okay, so for this one we have seen two examples. One example is the mathematical expression, where we have identified that a complex problem can be resolved into several sub problems. And later on we have seen one more example which is related to Bloxwald, and we came to know that when there is a dependency between the sub problems, it will be very difficult to resolve them. Okay. So coming to the second problem characteristic, which is, can solution steps be ignored or undone? Okay, so what does it mean? For example, you take the same thing, which is the mathematical expressions. Whenever you are trying to solve the mathematical expressions, first we will try to provide a lemma. And then we will continue further. But after some time you have realized that this is not making us to get the solution. This is not making us to get the solution. So in this case, what we have to do? We should simply ignore this lemma. Why? Because this lemma is not making us to solve the mathematical expression. So what we are doing here, whatever the lemma we have provided so far, that lemma we are simply ignoring. We are simply ignoring, right? Ignoring, and then later on we are trying to start, means we will start the problem solving once again, right, with another one to prove the theorem. Means whatever the lemma we have provided earlier, that lemma is not considering at this moment. Why? Because it is not making us to give the solution, making us to get the solution. So simply we are ignoring that provided lemma, and then we are trying to get one more lemma which can give the solution to the mathematical expression, or we can say solution to the proving of the theorem. So in this case, what happened? Whatever the first thing we have provided, that we are simply ignoring. Okay, so that is a characteristic. Na? So what is that? Can solution steps be ignored or undone? Okay, so here we have seen one particular scenario where we can do this ignoring of the already provided solutions. Let us try to understand when this undone will be possible. Okay, for that one, let us try to take an example which is nothing but the 8 puzzle problem. Okay, the artificial intelligence concepts are clearly understandable when we are taking the examples for each and everything. That's why I am trying to explain examples for each and every characteristic of the problem. Okay, so in this case, what we are doing, we are trying to discuss the 8 puzzle problem. So if you try to understand this 8 puzzle problem, we make a wrong move and realize that mistake. So think that what happens here in the blocks 8 puzzle problem. Sorry, in the 8 puzzle problem, we are going to have 4 different moves. Means we can say 4 different moves or 4 different legal moves. We can say, means a tile is given to us. This is an empty tile. Empty tile is given to us. So what we have to do, by making use of this empty tile, we have to adjust these numbers in such a way that you should supposed to get the goal state. Means these particular numbers need to be arranged in such a way that is given in the goal state. So what are the legal operations that you can perform? Means either you can move the tile up, empty tile up, or you can move the empty tile left, or you can move it towards right, or you can move it towards down. Okay, so what happened? Think that in a particular state you have done this right move. You have done this right move, but unfortunately it has been observed, that means you have observed that making this right move will not make us to move towards the goal state. Okay, so in that case, what happens? You should supposed to come back. You should supposed to come back, right? So come back, and you should supposed to select either up, left, or down. Means based upon the applicability, which one is very much applicable. But in this case, what happens? Until and unless you keep the track of all your moves, means whatever the moves you are performing while solving this 8 puzzle problem, all those moves need to be tracked. Means they need to be recorded. They need to be recorded. That means that here the primary responsibility of the control strategy is it should supposed to keep track of all the moves that we are performing while solving this 8 puzzle problem. So whenever such kind of tracking is there, simply you can come back. Simply you can come back and you can make use of the other moves. You can perform the other legal moves. So coming back and trying to take the other move is nothing but here backtracking. Backtracking. So how this backtracking has been supported for us, how it is supporting us, because we have, means the control strategy has keep track of all our moves. So whenever that is there, means whenever all our moves has been recorded, then immediately if you feel that one step is not making us to move towards the goal state, simply you can come back and you can try it in other directions. In this case also the same thing. You have applied the right operation, but you found that this is not making us to move towards the goal state. So simply you can come back. Why? Because this control strategy has provided all the moves to us. So you should supposed to come back and you should need to try the other legal moves. Means in this 8 puzzle problem, we can say that there is a possibility of backtracking because of this control strategy. Okay, so in this case, what happened? Whenever you are trying to solve these kind of problems, what happened? You have performed the undone operation. You have performed the undone operation. Why? Because you went forward and you feel that it is not your solution, or it is not your expected state, then you came back. Okay, so you need to observe these two things, whether your problem statement or your problem characteristic is related to the solution, ignoring of the solutions, or the solutions need to be undone. But if you observe the other kind of problems like playing of chess, in playing of chess you should not supposed to apply this character. Your problem statement should not supposed to have these things. Why? Because whenever you perform a certain kind of move in the chess playing game, you should not get ignored. Means you should simply, you cannot ignore, or you cannot perform the undo operations. Why? Because undo operation is completely not a legal move while playing the chess game. Means what I am supposed to tell, the problem characteristics, whatever we are going to discuss in this section, all those characteristics are not going to be applicable to all kinds of problems. Means the problem characteristics for each and every problem will be different. So by understanding the different problems characteristics, we should supposed to know what is the general behavior of the problem, to which kind of solution that which kind of scenario that problem is belongs to. Okay, so simply we can say that we are trying to understand the behavior of the particular problem. So just now what we have discussed is the three things, which is the theorem proving, 8 puzzle problem, and the chess. Means whenever it is the theorem proving, simply we can say that whatever the solution steps you got, that solution steps simply you can ignore. Why? Because you thought that the solution step is not not proving the theorem. So in that case, you can simply ignore that solution and you can try to get another kind of solution, new solution. So in that case, we can say that the theorem proving is completely, the solution steps that present in the theorem proving are completely ignorable. And the solution steps that present in the 8 puzzle problem, simply they are recoverable. Why? Because the control strategy is keeping track of all the moves. So whenever if your move is not the expected move, then simply you can come back and you can make the other move. That's why we are saying that this 8 puzzle problem, the solution steps related to this 8 puzzle problem are completely recoverable. So what it comes to the chess playing game. So in the chess playing game, whatever the solutions you got, or whatever the solution steps you have obtained, those solution steps are completely irrecoverable. You cannot recover them back. Coming to the third characteristic of the problem. What is that? Is the problem universe predictable? Means is it possible to predict what is the next coming step? Okay, whenever you are trying to apply a particular rule or particular operator to a given state, so what new state it is going to come. So most of the cases what happens, the AI related problems, means especially if you are dealing with real kind of AI problems, the predicting of the future states is completely not possible. So you should suppose to understand, is your problem is related to this particular case or not. So whenever you are trying to solve your problem, can you make an expectation of what will be the next step you are going to get. So if you take the example of the same thing, which is the 8 puzzle problem. So in the 8 puzzle problem, we can clearly say that we can clearly tell what will be our next step. So in that case, what happens? We can say that it is universe predictable. If you are dealing with 8 puzzle problem, then definitely whatever the newly states going to come, that states already you can predict earlier. Why? Because there are only some possible moves are there. When there is some possible moves, easily we can say, if you make left move, you are going to get this state. If you make the right move, you are going to get this state. Simply we can predict it. Okay, you can predict it. So in this case, what happens? Simply you can plan the entire sequence of moves. You can plan the entire sequence of moves and be confident what the resulting state will be. So as you are planning the entire sequence of moves, simply you can say that which moves will makes us to move from the given state to the desired state. If you find any of the state, if any of the move is not making to move towards the goal state, simply you perform the backtracking. Okay, so with this explanation, we can clearly say that if you are trying to resolve the problem which is related to 8 puzzle, then simply the newly going to come states are easily predictable. We can easily predict them. Okay, for example, we will try to take one more example, that is playing of bridge. So this we can say that in this particular case it is completely unpredictable. Unpredictable means this is some kind of card playing game. So in this card playing game we cannot know that where our desired cards are, and also our complete solving of this problem or playing of these cards completely depends upon the other player. So what does it mean? Means this problem is related to the uncertainty. This problem is having some uncertainty. Right? Certainty means what? Certainty means already you can predict what is going to come next if you make this kind of move. If it is uncertainty, that means that you cannot predict what is going to be the next state, what is going to be the next one. Okay, so if you talk about this playing of bridge, simply we can say that it is the problem with the uncertainty. But in the 8 puzzle problem, it is not the case. So what we have to do, if you are trying to resolve this kind of problems, you should supposed to follow the process of plan revision. You should supposed to follow the process of plan revision and carry out the necessary feedback. Means you have to follow a particular sequence, and you need to give the feedback for each and every sequence you have followed. But there are some complications in this. There are some complications. Let us try to see that one. So the best way is to investigate several plans and use the probability of various outcomes. Means what we are doing, we are not just trying to get one solution for the problem. We are trying to get the different possible solutions for a single problem. And what we will do for each and every problem, we are going to give some probabilistic value. So based upon the probabilistic value, means the probabilistic value for which solution is higher, then we say that solution is the best solution to make use of it. Okay, so but there is some kind of disadvantage in this. So what is that disadvantage? Planning in this case is often very expensive. Why it is expensive? Why? Because we are not stopping just by getting one solution. Means whenever we get one solution, but what we are doing, we are trying to get, or we are trying to obtain the other possible solutions also. So in this case, what happens? We can say it is going to take a lot of time. Expensive in the sense, in terms of the time. Okay, coming to the fourth characteristic. So what is the fourth characteristic? Is a good solution absolute or relative? Okay, so whatever the solution we got, whether that solution is absolute or whether that solution is relative. So what does it mean? Let us try to understand this concept with an example, which is the traveling salesman problem. Traveling salesman problem. For example, see in this table, right? Okay, so this table is telling all about the distances between some cities. So what does this traveling salesman problem is? The salesman is given some n number of cities to make a visit. So that visit is a regular visit. So in that case, what happens? The salesman is going to look for the shortest path so that he can visit all the cities given to him. Okay, for that one, means in order to identify the shortest path, the salesman should supposed to know the distances between the cities. So this table is telling all about that one. So these numbers are representing the distances among the cities. So what does this 1200 is representing? 1200 is this is representing as the distance between the Newark and Miami. Okay, so by taking the help of these distances, you should suppose, the salesman should supposed to identify the shortest path. Okay, now the question comes is, if we identify only one particular path, you try to observe this particular case. If you are trying to identify only one particular path which can cover all the cities given to the salesman, then what happened here? From the table values, you came to know that the total distance is going to be 8,850. Okay, so is this result absolute or relative? So here we can say that this is completely relative. Okay, why it is relative? Why? Because you have identified only one possible solution. Why? Because you have taken only one path. Until and unless you explore the other paths between the cities, you should not supposed to tell that this 8,850 is the shortest distance between the cities. So that's why what need to be done, you should suppose to get the path that is completely absolute. So what we are doing, we are trying to resolve, or we are trying to observe the other path also, which can cover between the cities. So in this case, what happened? In the first case, we got 8,850 distance, and in the second case, we got 7,750. Means after trying to identify all the possible paths between the cities, we came to know that 7,750 will be the shortest distance between the given cities. So ultimately, the salesman is going to select this particular path to make the move every time in between the cities. So you should suppose to understand whether your problem solution is giving a relative solution to us, or the solution is completely absolute. Okay. Next, the fifth characteristic. Is the solution a state or a path? So this is little bit difficult when compared with the other things. Okay. So let us try to understand. So in order to understand this problem characteristic, we have taken an example. What is this? There is a statement. Let us think that there is a statement which is that the bank president ate a dish of pasta salad with a fork. So here we can say that this problem is related to some natural language problem, or we can say that it is some kind of it is involved with some kind of common sense reasoning. Okay, so what is the statement given to us? The bank president ate a dish of pasta salad with a fork. So what is happening? There are several components in this sentence. There are several components in this sentence which are giving more than one interpretation. You try to understand. The bank president. Whenever I say it is bank president, okay, so it can be anything. Anything means it can be the president of the bank, some HDFC bank or Axis bank, like that. But what happens if I say only bank, that means that it can be a bank of a river. Bank of an ocean, we can say bank of an ocean. So how the AI machine should understand this bank? Why? Because if the AI machine is having the common sense, simply he can understand bank president means the president of some Axis bank or the HDFC bank, like that. But if your AI machine is not incorporated with any common sense reasoning, simply it will be in the dilemma to understand what kind of this bank is. Simply here you see, if it is 8, that means that we are talking about eating. Means the bank president is doing eating process, we can say. So what he is eating? He is eating a dish of pasta salad. A dish of pasta salad. So what does it mean? Means he is taking a solid which is made up of pasta. So how he is eating? With a fork. So here also some kind of confusion is there. Some kind of interpretations, different kinds of interpretations we can do. Means fork means what kind of thing it is? Means the fork means which is some object, an object which is used to do the eating. You can consider like that, right? So what happens if you replace? Means what happens if you replace this one with friends? The bank president ate a dish of pasta salad with the friends. So this is going to give the entire different meaning when we are using the friends in place of the fork. That means that these kind of representations are going to give more than one interpretations. So the AI machine should suppose to understand more clearly. So in this case, we can say that if you try to resolve this particular problem, we can say that the solution what we are going to get is representing the state in a particular world. The state in a particular world. Why? Because here you try to observe here also. If I say dish of pasta salad, so what does it mean? He is eating solid which is made of pasta. Of course, we the human beings, we can clearly understand this that this solid has prepared with some kind of pasta. Okay, so if I say that it is the if I say that this one, you try to understand. Dog food does not normally contains dog. So previous case, what happened? If I represent this pasta salad, that means that we are explaining that this solid is prepared with pasta. So it does not means if you are representing this dog food, that dog food representation will not have any word called as dog. Okay, so these kind of complex problems are going to be there, which are related to almost the natural language problem, or we can say which involves some common sense reasoning, which needs some common sense reasoning. So in this case, if your problem statement is belongs to this, if your problem statement is having this kind of characteristics, then we can say that your solution will be a state in a given world. Of course, it is not a path. Okay, so these are the things which I have already explained. If you replace this a fork with the vegetables, we are going to get different kind of structure. If you are going to replace that forks with friends, it is going to give different kinds of structure. Okay, so modifying several parts of sentences are going to give different kinds of interpretations. So that means that there is lot of ambiguity that is present in that particular statement. Okay, next we try to understand this one. Whether your solution is a path. So what does it mean? Let us try to understand. Think that you are resolving a problem which is called as a water jet. So in this water jet problem, generally what happens, a initial state will be given to you. For example, think that this is the initial state, means two jugs with empty, two jugs empty jugs we can say. That means that there is no water in the first jug and no water in the second jug. So what you have to do, from the given state, you should supposed to get the desired state. So what is the desired state? The first jug should exactly contains 2 liters of water and the second jug should be completely empty. Okay, so what is happening here? You see, on these jugs there will be no markings. Then how you are going to get exactly 2 liters of water in the first jug and keeping the second jug empty? So if your problem statement is related to this one, so simply I cannot give the solution as 2, 0. Why? Because I should supposed to give the explanation. A path need to be given. A path need to be given. So how the path will be? If it is first 0, 0. So first what you can do? You can fill up the first jug with completely full complete water. So what does it mean? 4. If I represent 4, the capacity of the first jug is 4. And other possibility what I am having is I can keep the first jug empty like that, and I can fill the second jug with 3 liters of water. So this is one possibility. So like this, we are going to have several possibilities. We are going to make a move like this. So if your problem solution means if the solution to your problem statement is a path, simply you should not supposed to tell that this is our solution. You should supposed to give the complete path which is making us to move from the given state to the desired state. Okay, so with this explanation we can say that the first example what we have taken, which is related to the solution as a state, and the second problem is related to the solution as a path. The sixth characteristic, what is the role of the knowledge? Do really we require knowledge in order to solve the problems or not? Let us try to take one example. So the problem of scanning the daily newspaper. The problem of scanning the daily newspaper. So what happened? Let us think that this problem is given to the AI agent and we ask to resolve it. So do really we require to solve the knowledge to solve this particular problem or not? We will try to see this. So what is the scanning of daily newspaper should tell? Means a task is given to the AI agent telling that whether you are going to support the Democrats or you are going to support the Republicans in the coming elections. So in order to give the answer for this particular problem, definitely you should supposed to have knowledge. You should supposed to have knowledge. Now the question is, how much knowledge would be required by a computer trying to solve this particular problem? Okay, so you should supposed to have the large quantity of knowledge only. Okay, so if it is a case, you should supposed to know the candidates of the party, and you should supposed to know who is going to reduce the taxes. Okay, so if the name of the candidate and if the party is lowering the taxes, then simply we can say that we are supporting the Republicans. If any of the party is supporting the education of the minority students, and then we can say that we are going to give the support to the Democrats. Means you should means simply by taking one or two statements, you cannot resolve this particular problem. So what you need to have the large quantity of knowledge. So in this case, we can say that the having of large quantity of knowledge is very essential while solving these kind of problems. Okay, so you need to understand whether your problem statement is related to this particular characteristic or not. And the seventh one is, does the task require interaction with a person? So this is very, very important. So what happens here, at one level of interaction between the computer and the users, so what it will be, problem in, means we have given the problem to the computer and the computer has given the solution to us. So generally it will happen like that. The user is having some kind of problem, that problem will be given to the computer and that computer will give the solution to us, to the user back. But for all the problems, it is not the case. So what happens to some kind of problems, there should be a need of this intermediate interaction. Especially if you are dealing with diagnostics, medical diagnosis, what happens? Simply giving the results and telling that the patient is having some kind of cancer, right? It will not make any sense until and unless the doctor has given certain kind of reasoning for that results. Then only the patient is going to get convinced. So in that case, what happens? Simply having the solution does not matter. Definitely after getting the solution, definitely there should be an interaction between the patient and the doctor, so that the doctor can give the reasoning. Means what are the reasons that made the patient to get that cancer. So whenever that kind of explanation is given by the doctor, then immediately the patient is going to get convinced. So in that case, what happens? Simply giving the solution does not matter. You should supposed to make a continuous interaction with the computer and you should supposed to get the reasoning also. Means what happened? You should supposed to have the additional information also. This additional information we need to provide to the user. This is nothing but some kind of giving the assurance to the user. Okay. So does the task require interaction with the person? The same thing. Let us try to distinguish two different problems. So one problem is solitary. So what does it mean? Means there will be no intermediate communication. There will be no intermediate communication. That means that in this particular kind of problems, only giving the problem to the computer and getting the solution from the computer only matters. We never involved with the reasoning kind of things. Means having the continuous interaction with the computer once again, repeatedly we can say. But there is another kind which is called as conversational. So in this case, what happens? After getting the solution also, still we are going to maintain some intermediate communication between the person and the computer by providing some additional assistance, or we can say by providing some additional information to the user. Okay, so we are going to see these kind of things, especially when we are working with chatbots. Okay, the chatbots, what happened? The user is going to communicate with the computer continuously. So such kind of problem statements, we can say that it is conversational. Okay. And the eighth most characteristic is the problem classification. So you should supposed to understand, you should supposed to determine whether your problem belongs to this particular category or not. Means if your problem is related to the classification, then what you have to do? The task is to examine an input. Means first we are going to examine the input, what input we got. Then after we are going to decide the set of known classes the input is an instance of. For example, think that a cat image is given to you. A cat image is given to the computer, right? But the computer does not know that this is a cat image. So this image is given as the input to the computer. The computer is going to identify the features that present in this image. Based on that image features, it is going to decide to which class this image belongs to. So if the computer could able to extract the features more clearly, more accurately, then easily after the processing, it is going to tell exactly that the image given to the computer is a cat. If it is a dog, it is going to classify it as a dog image. So how this classification is performing? Means by examining the inputs given. So if your problem statement is related to this kind of thing, then we can say that it is related to the problem classification. So what we are having many design and planning problems that can be attached with this strategy. Okay, we can say that classification is one kind of problem related to this one. right? In this classification, we can say the sub problems, we can say either it can be the detection, or we can say that it is some kind of recognition. Okay, so different kinds of strategies are going to be there in this. Means if your problem is related to these kind of things, then we say that the characteristic of your problem is related to the problem classification. So these are the 8 important characteristics of the problem. So you should suppose to explore, you should suppose to understand the characteristics of your problem statement, and based upon the characteristic, means to which characteristic your problem statement is exactly matching. For that one, you should suppose to select the appropriate heuristic search technique to apply. Okay, whenever you select the appropriate heuristic search technique, easily you can resolve the problem and you can get the solutions. Okay, so this is all about the problem characteristics, and we will come up with the other section, other topic in the next section. Thank you. And these are the references I have used to prepare this particular content.
Like, share and subscribe. Hit the bell icon for more updates.